have written 4 different surds here, mixed surds, and this last one is a pure surd. I want to add it. I can add it only if the surd part, the radical part, has same number inside the root. You can see the number inside the root, they're all different. So you cannot add them. So what you need to do first is to convert it into a simpler surd or smaller surd. So you get smaller numbers here. Let's see how you can achieve that. So the first radical that I have here is 125. If I have 125, I need to divide 125 by its factor, prime factors. So the first number is 5 that I'm trying with. So 5 times 2 is 10. The remainder is 2. It becomes 25. 5 5s are 25. Again 5 times 5 is 25 and eventually 5 ones are 5. So I can write 125 as a product of its prime factors, that is 5 times 5 times 5 minus 10. Now let's see how we can split 32 into its primes. My next number here is 32. So 32. 2 ones are 2. 1 left. 2 6 are 12. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4. Eventually 2 ones are 2. So if you can see, we have 1 2 3 4 5 2's. In place of 32, I am writing it as a product of its prime factors. 5 2's. The next number is 245. We'll achieve the same thing with the prime factorization method. So I have 245. What number should I start with? 245. Again, the number at the units place is 5. So which means I can divide it by 5. 5, and I cannot divide 2 because 2 is smaller than 5. So however, I can divide 24 by 5. So 5 times 4 is 20. Remainder is 4. I get 45. 5 times 9 is 45. This 49 is divisible by 7. 7 times 7 is 49. Then 7 times 1 is 7. I got the prime factors of 245. They are 5 times 7 times 7. Lastly, I have 18. 18 can be written as, so I know that 18 is 2 times 9. So 2 times 9. 9 again is a composite number. However, 9 is a perfect square. You must be aware of the fact that inside, if you want to convert larger surds, higher surds to simpler surds, we either write it as a product of its prime numbers, or we split it into its factors, such as so that you get either a prime number or a perfect square. So 18 can be written as 2 times 9. You can see that the square root of 9 is 3. You can however also write it as 3 times 3. So you still get the same answer. After this step, we have to pair numbers. Why I have paired 2 5's and not 3 5's is because it is a square root. Square root means we pair two numbers together. If it was cube root, we would have paired 3 5's together. From here, if it's a square root and we have paired 2 5's together, if you multiply 5 times 5, you get 25. So square root of 25 is 5. So I get 4 times 5. So it is no more a surd. It becomes a whole number. However, the unpaired number remains inside. Minus 10. The same logic is applied here. I make pairs of two numbers. So I have 2 times 2 is 4. Square root of 4 is 2. Again 2 times 2 is 4. Square root of 4 is 2. The unpaired 2 remains inside. Here I have a pair of 7. 7 times 7, 49, and the square root of 49 is 7. 7 times 5. Unpaired number is left inside. plus. I have used a different method here. I have not written it as a prime factors. I've explained that already. So square root of 9 is 3. So I get 3 root 2. You can either use complete prime factorization method or splitting a number into its primes and a product of its perfect squares. Okay, so what I have is 5 fours are 20 root 5 minus 10 times 2 20, 20 times 2 40 root 2, 5 times 7 is 35 root 5 plus 3 root 2. We started with 125 and 32 and 245 and 18 inside the root. However, we ended up with smaller numbers. So you can see that we have simplified surds, broken them down into simpler surds. After this step, we need to group like surds together. What do we mean by like surds? Like surds are surds with the same numbers inside the root. I have root 5 here, I have root 5 here. So they can be solved together. I am writing them together for your ease. 20 root 5 plus 35 root 5, and then after that I have the next pair, which is 40 root 2 and 3 root 2. So I'm writing them together because they are again like surds with root 2 inside. Now we can add or subtract like surds. 20 root 5 plus 35 root 5, you just add whole numbers, you get 55 root 5. While adding or subtracting surds, always make sure that you only add the whole number part of the surds and the radical part is never added. It is written as it is. Minus 40, negative 40 plus 3. You end up with negative 37 root 2. In this step, if you see, we have different surds, unlike surds, and unlike surds cannot be added or subtracted. So you cannot simplify it further. This is your final answer. I hope the method is clear to you.